Hi physics students, so this is going to be a demo of how to use Google Sheets to help you with the ball bounce lab, like the actual ball bounce lab data sheet, how to use the Google Sheets formulas that we just reviewed to calculate various things in the lab data sheet. So the very first thing you would want to actually calculate is changing the mass in grams to kilograms. So if you notice, I'm actually going to do something really quick so you can do error analysis if something goes wrong. Let's say that I had this in the cell, 4.2 G, which is for grams, okay? And let's say I'm now trying to convert this into kilograms. Now I know that there are 1,000 grams in a kilogram. So the way that I would normally do this is put equals, which is what we start with for any kind of formula or function in Google Sheets. You always start with the equal sign, symbol. Equals, click on the cell, divided by 1,000. Notice that this does not work, okay? Now, why does this not work? Oftentimes, it'll tell you an error message. So if I click on this, it tells us error. It expects number values, but 4.2 G is a text. Now, why is it a text? It's because there's that letter G. Okay, so I'm just going to delete the G, press enter, and boom, it solves it for you, okay? So 4.2 grams is equal to 0.0042 kilograms. And that's why oftentimes I put the unit next to, for example, this variable which is for mass over here. So you know that whatever's next to it is in that unit. Okay, so it's 4.2 grams, 0.0042 kilograms. They are the same thing. Now, why are we converting it to kilograms? Because kilograms is the standard unit for mass in physics. So anytime we see a mass, we are going to convert first to kilograms before we solve anything, okay? So now that we have that, we can go back to our table. I've actually inputted random data here. Just ignore that. You should be getting your own very exciting data from the lab. I literally just made up numbers, as you can see. It's very formulaic, pretty formulaic here, and then I had to adjust some numbers up in the front. So let's go ahead and start with this. We need to now calculate the gravitational potential energy of the drop heights, okay? So how do we do that? We do that using this formula right here, that gravitational potential energy is equal to mass times gravity times height. So what I can do is I know that acceleration due to gravity, okay, is equal to 9.8. That's the value. Now I want to refer to this value whenever I'm calculating any kind of gravitational potential energy, okay? I want to plug it in for G right here in the formula. So let's go ahead and work that out. So the first one over here is going to be for a drop height of 0.4. And I actually want this value to be relative to the cell. So what do I mean? When I have the formula for GPE over here, which is mass times gravity times height, I want the height that we're using to be the one directly to the left of the cell. So I'm okay with that staying as a relative reference. Okay, I'm not going to put the dollar signs there. Now for the mass, I don't want that one to be changing. I want this one to stay as B6. So I'm going to go ahead and, add the dollar signs in front of the B and in front of the 6 to lock that as the value we're using for mass. Now I'm going to do times, again, I want this value to stay the same, okay? I want it to always be 9.8 that we're referring to. I'm putting the dollar symbols. Now for the drop height, I'm okay with it being relative. I want it to change as the cell is moving down. So I'm gonna press enter, calculates it for me. Sometimes they have a suggested autofill that you can click on this check mark and it'll fill the rest of it. I'm just gonna ignore it for now and teach you the other way. Okay, so now what we can do is if it doesn't do the autofill, you can click on that cell and you see this little blue square. You can click and drag it all the way down and it should apply that same formula across the board. So if I click on this next box, you'll notice that again, we are still referring to B6 and E6, but now it's A11, which is exactly what I want. I want it to use the drop height 0.5. Next, it's A12 now, but the other two are staying the same. Next, it's A13 now, but the other two are staying the same. That's what I want, okay? I want B6 and E6 to stay the same, so I'm putting dollar signs in front of them. I want those values to stay constant, because they are. The mass is the same mass. Acceleration due to gravity is just 9.8 when we're on Earth, but I do want to change the drop height. So that's why I set the formula up the way I did over here, okay? The next thing is you do your lab and you get bounce heights. Again, I just made random numbers up. And once you have your bounce heights, you can calculate average height. Now, average is one of the Google functions. So I'm going to go equals, start typing in average, put the parenthesis, and then you can go ahead and click and drag to select the values you want to get the average of. So in this case, for this row, it is C10 all the way to E10. Press enter. I'm going to autofill this time, and it calculates the rest of it. Okay. Next up, we're going to get the average gravitational potential energy of the bounce height. And so this is very similar to the gravitational potential energy of the drop height, but instead we're using bounce height now. Okay, average bounce height. So now I'm going to do equals. Again, it's the same mass, and I don't want this cell to change. So I'm going to put the, oops, I keep doing that. I'm going to put the dollar signs in front of the B and in front of the 6 to lock that cell's value. I'm going to multiply that by G, which is 9.8. Okay. I'm going to put dollar signs in front of it to lock that value and multiply it by now a relative cell, which in this case is F10. Why? Because I want the next one to be using F11 as the height, the one below to be using F12 as the height, so I'm not putting the dollar signs in front of that one. So I'm okay with this changing as the height changes, okay? So now you have your table completed using Google Sheets, okay? And your next step on your individual document is actually to create a graph. So I'm going to teach you how to do that too. Now your graph is going to have drop height on your x-axis. That's what they tell you in the document. And then the two gravitational potential energies, the one for drop height and the one for bounce height, as your two lines based on the y-axis, what you're measuring. In this case, it's gravitational potential energy. So I'm going to go ahead and click and drag to select these two columns first. I'm going to go to edit, copy, and I'm just going to go ahead and actually I'm going to edit, paste special, and put the values only because I want the numbers. Okay, if you were to just paste it as normal, I'll show you. Edit, paste. Okay, I guess it worked in this case, but sometimes the values change. So just to be safe, I'm going to do edit, paste special, values only to save those values. Same thing with average gravitational potential energy of the bounce height. I'm going to edit, copy, edit, paste, values only. And now I have this table which has drop height as the x-axis, and these two are the things that we're measuring. Gravitational potential energy of the drop height, average gravitational potential energy of the bounce height. So you're going to select all of this data, go to insert, and then you're going to go to chart. All right. And then you can choose whichever graph you want. So in this case, we specify we want a line graph, okay? And then we just make sure we have all the things. So I have drop height labeled down here in meters. That's perfect. I know that I'm going to have to customize it and add an axis title on the y-axis. I'm going to go here to vertical axis title. And this is going to be gravitational potential energy. And that's in J, joules, okay? And then I'm going to also adjust the chart title, because in this chart, we are measuring gravitational potential energy of drop height and bounce height at various, or from various, drop heights. In here you can also, there we go, adjust and add the units. So joules for gravitational potential energy. At the very end, meters for the various drop heights. All right, I hope that helps you with completing your ball bounce lab, your group document, as well as your individual graph. If you need more help, you could go back to the video and rewatch the parts that you're stuck on. You can also look back at the tutorial video for Google Sheets, and that should help you with different formulas as well. Thank you so much, and I look forward to seeing you in class. Bye.